So it's pretty immaculate. Yeah, it is. Wow. So we want our little stub of a power lead. Let's have a look at this serial number then. That's a bit dirty. (8680) 208 680. Right, I'll get the mic plugged in. Now, I'm not a lover of sets with loads and loads of... Hang on, there's a screw missing out of there. Knights at near Gainsborough sell those. They're 25p, and it's the teeny weeny screw. Luckily, we bought some. So how do you lose that? 13.8 volts. Picture in picture on. Transmitter test set to 3 watt scale. Switch radio on. Oh, it helps if I'd have connected the power supply up to the power lead. So we're in PA at the moment. 1212, we're testing 1 2 3 4 5 5 4 3 2 1. So that works. Normal, off, normal. Can I hear any difference? Yep. What's it going to be then? Is it going to be 4.5 watts and need to come down? Is it going to be 2.7 watts? It's going to be just about 3. So low power, go back to channel 20. (120 milliwatts). Transmit current, go back to normal power. 973 milliamps. Deviation, wallow, wallow, wallow. Yeah, right. 4.8 kilohertz. Bet they love listening to them on channels either side. Now we'll take this frequency with a pinch of salt. The test set's only been on 10 minutes. It needs to be on half an hour to get an accurate reading. Yes, that's going to be fine. We'll pull it up a bit. 79092. That's not out of spec. We'll go through the receive. I'll set the signal generator to the same as the transmitter, so that it's a fair test. will do me. And straight away I can hear it receiving. So we'll switch the cyanide meter on, go over to that. This is good. 0.98 for 20 dB. 0.36. 0.28. Well, I don't think we're going to be getting that any better than that. Squelch to full. I like them to come in at 100 microvolts. So let's go to the attenuator so you can see me doing that. So at 1, 3, 10, 30. It's coming at 30. We want it stronger than that. It's 28 microvolts it's coming in at. And the threshold. Signal generator to standby, set the squelch threshold on the radio. .2, no, 0.68. That's fine, that's not. So S meter, oh, meter lamp's okay, sockets are okay, PA's okay, mic's okay. So when we key up, bearing in mind the set's doing 3 watts, let's go back into the transmit test. It bangs across at 4.5. So that's wrong. And on receive, let's put 100 microvolts on. That should now read S9. It doesn't, it needs a bit more than that. It's exactly 300. Check the channel 9 switch works for whatever reason that's there for. Good, right, we'll get it opened up. Shenanigans? No, we can't. It even smells newish. Considering it's 40 years old, it certainly looks it. So we'll put it to channel 40 and we'll start with VCO. So, still with Mr. Chippy's lead, although Alan has kindly sent us some leads, we're not on that box yet. Don't take prezzies out of boxes until they are due. So it's supposed to be 4 volts on receive. That's neither here nor there, but we may as well drop it. And on transmit, it's supposed to be 4 volts. 3.3. That actually needs a bit more than the other. So shall we turn it to the right or shall we turn it to the left? Let's turn it to the left today. Yeah, chose wisely. 3.98 and on receive 3.984. Let's go to channel 1. Somewhere around 1.8, 2.3, somewhere around there. That's fine. On receive and on transmit it's fine as well. So that's the VCO done. So it shouldn't have channels dropping out. Put Mr. Chippy's borrowed crocodile clip away. So, with the meter back on there. We're going to tune up the transmitter for maximum. Not on that scale, we're not, we're already beyond him. So no difference there. Slight difference. Are we on channel? No. Done it again. Change to channel 20. Start again. So that's all peaked. So with the plastic trimmer we need to quite quickly tune this up. I've said before, ideally this will do above 4.4 watts so we can make the adjustments properly. Sometimes you see them left at full whack power, and that is absolutely ridiculous. It's not why they can do more power, it's so they can be balanced properly. It's like driving a car at 100. You know, something's going to go, and it will. So legality aside, the legal limit's 4 watts. But that aside, the radio cannot sustain the maximum power it can generate. That's just a bit of headroom. This particular one is doing 4.2. That with that one, 4.4, and that one's not going round at all. Why is that? I don't know what we're going to do there. I've got the right tool and it's not moving. I hardly dare put the wrong tool in. I'm just trying to feel it. Have we got the other series, the green one? My trouble is I'm too kind and I lend people these very specialist tools. Might be able to move it with that. Yeah. So we're up to about 4.8 there. That's just a whisker away from 5. Right, here goes. So clockwise for 4.4 watts. And then anti-clockwise, the manual says of 3.8 watts, but we want the full legal limit. We haven't got to get it through a customs post where they might say, oh, we're rejecting the whole batch because that one's doing 4.01 watts. And that's why they're set low. So that's now 4 watts. Those live between 2 CRT monitors. Right. So we've now got 4 watts. Let's go to channel 40. Got 4 watts. Channel 1. We've got 4. Hey, I tell you what, you don't often get that. It's supposed to be 0.1 in between them. But this one is like perfect. Right, may as well set the meter. So the RF meter's there. I've said a million times, it's only a relative if you're into a dummy load. When you put it on an aerial, it might read 1, might bang across, still doing 4 watts. Just because it says 1 on the screen, it doesn't mean it's only doing 1 watt. Low power. So it was doing a lot less, it still is. Let's just spray that preset because it can get dirty. they're rather prone to it. They're also prone to failing. There we go, 400 milliwatts. Back to normal power. See what the current consumption is now. 1.15 amp. Another watt for not a lot more power. Wow, this deviation is ridiculous. So the vertical one needs to be in its central position. So I found this is the best way. And then we'll deal with the deviation on that preset. Wallet. Might going down or something. Wallow. Well, it doesn't want to go with the normal routine. Now, I just find this bizarre because the deviation was ridiculously high. So, it's my test set playing silly, what's it? It's only doing 2. We're going to have to come back to that. I don't think the radio's faulty. I think we've got a false reading for some reason. Right, so we've, apart from that, we've done that. We've done the transmit. Oh, I'll tell you what, we'll do frequency. Been on long enough now. There we go. Right. So go back to the receiver. And just reset the signal generator now the radio's on frequency. There we go. So it's going to start with the detector. So 100 microvolts. And we'll put the oscilloscope on, pop the bench light off, and go over to, oh, it's camera 3. A little bit less volume so I can see it. And maximum recovered audio. Very, very slightest adjustment there. Over to the sign-up meter. So 4 dB on there. I'll tell you what, we've gained something there. Not there. The biggest signal on for these IFs. There we go, let's get a reading now. So for 20, we've got 0.84, that's very good, isn't it? 0.84. For 12, It's nearly as good as a Binary 75 star, this. 0.31 and for 10, 0.23. So we'll set this signal meter, so it's got the thing on 100 microvolts. We need to bring that up a little bit. That's now 100 microvolts. Done that. This squelch. So I'll put the squelch to full, and I will advance the attenuator until we get to 100 microvolts, at which point the signal generator should come through, opening the squelch. So 10 microvolts, 30 microvolts, 100 microvolts. It's exactly where I want it to be. So the fact we've done a bit of a retuning on the receiver has brought that exactly right. So now we'll just check the sensitive end, see where threshold is now. So set threshold with the knob on the radio. It's 0.24 is it? No, it's not. It's 0.76 microvolts. That's it, we're done. Yeah, glad to have been able to sort that out. We're going to come back to that. I'm going to do a church service, come back about 19 minutes, 2 hours later, and just see what's happening there. Okay, so I've got to the bottom of the deviation. There's something just gone astray with the deviation meter built into the Marconi test set. It's reading low, so when we started off and it was reading 4 kilohertz, whatever it was, that was right, and then suddenly it started going low. So I thought, well, why is this thing not producing the deviation? So I've just plugged my walkie-talkie in, and that was reading low as well. So what I've just done to get out of the situation is to plug in an external deviation meter. So we'll just set it with that instead. So that is now as it should be. So that's it. We'll button the setup and we'll do an on-the-air test. So we'll start by putting some screws together. I did take the bottom off in case there was something wrong underneath, but as you can see, it's absolutely immaculate. We'll start by putting that lid back on. Right, so we're now on the roof area, the Antron 99 or whatever it is. One 9 Roger. 19 Roger. Helps her on high power. Distant conversation there. Okay. We'll just listen to ourselves. I'll just listen to myself. Setting 1 2 3 1 2 3. Setting 1 2 3 1 2 3. Good. So we'll do an on-the-air test. And I'm sure that'll work splendid with the receiver, as good as it is. That's a really exceptional receive. And 4 watts as well to go with it. So thanks for watching the rather immaculate York 863 and its box from 1981.